Conservation of energy is the idea that energy can't be created or destroyed, but simply transfers between different types. And one of the most common ones that we'll look at is gravitational potential energy converting to kinetic energy when an object is dropped. So if we look in this video, we can drop the ball. Now in this one it bounces back up, so there is actually some other potential energy involved while it bounces back up as well. And what we see is the kinetic energy starts at 0, so it's this blue line here, and builds up to a maximum when the ball hits the ground, and then comes back down towards 0 as the ball decelerates on the way back up. Meanwhile, the potential energy starts at a maximum when the ball was up the top, that's our mgh formula, and as the ball accelerates downwards, so you don't get a straight line here because the displacement is changing at different rates, it's increasing the rate at which it's changing. So the potential energy goes with that displacement, so it decreases to a minimum before increasing back to a maximum. And this, these two formulas then, it's quite a common situation where we're looking at converting between them, and if we set them equal to each other, we can see that the m can cancel out from both sides, and we get a simple formula for v at the bottom, which only depends on the height it's dropped from. Now remember, this is an ideal situation where there's no air resistance, no energy loss due to friction. And what we get then is that the speed it ends up at does not depend on the mass of the falling object. Now this formula can be used for objects in free fall, but it also works for objects like pendulums, which you can't use the free fall formulas for. So it's useful in that situation.